India is a country on the move. With a population of over 1.3 billion people, the demand for energy is immense and ever-growing. Its economy is growing fast, and this means India needs more and more electricity. The rapid urbanization and industrialization have led to an increased need for a stable and continuous power supply. Thermal power plants have been the backbone of India's electricity generation for decades. These plants are crucial in meeting the high energy demands of the country. These plants burn coal to produce electricity. The process involves burning coal to heat water, which then produces steam. This steam drives turbines connected to generators, producing electricity. Coal is a readily available resource in India, making thermal power a reliable and affordable option. India has vast coal reserves, which are essential for the country's energy security. Thermal power plants are spread across the country, ensuring a consistent supply of electricity to industries and homes. From the northern plains to the southern coasts, these plants are strategically located to serve the entire nation. While renewable energy is gaining traction, thermal power continues to play a crucial role. The integration of renewable sources like wind and solar is increasing, but thermal power provides the necessary base load to maintain grid stability. It ensures energy security as India transitions towards a more sustainable energy future. The combination of thermal and renewable energy sources is vital for a balanced and resilient energy system. In the coming years, thermal power will continue to be important for India's growth story. As the country aims for economic development and improved living standards, the role of thermal energy in providing reliable electricity cannot be understated. The ongoing advancements in technology and efficiency will further enhance the contribution of thermal power to India's energy landscape. India's energy demands are constantly growing. To keep up, India is building new thermal power plants. These plants are more efficient than older ones, using less coal to produce the same amount of electricity. This is important for reducing pollution. The new plants also use advanced technology to reduce emissions, helping to protect the environment. India is committed to providing affordable and reliable electricity. The addition of new thermal power plants is crucial to achieve this goal. These plants will power India's homes, businesses, and industries for years to come. India is embracing renewable energy sources like solar and wind power. These sources are clean and sustainable. However, they are also intermittent, meaning their availability depends on the weather. Thermal power, on the other hand, provides a stable and consistent supply of electricity. To ensure a reliable power supply, India is integrating renewable energy with thermal power. This means using thermal power plants as a backup. When the sun isn't shining or the wind isn't blowing, thermal power plants can quickly increase their output. This ensures a continuous flow of electricity to the grid. This integration of renewable and thermal power is key to India's energy transition. Section 4. Cleaning up the act, reducing emissions from thermal plants. Thermal power plants release emissions that can impact the environment. India is taking steps to minimize these impacts. Stricter environmental regulations are being implemented. These regulations set limits on the amount of pollutants that plants can release. Power plants are investing in technologies to reduce emissions. These technologies include scrubbers that remove sulfur dioxide from flue gases. They also use electrostatic precipitators to capture fly ash. These efforts are making a difference in reducing the environmental footprint of thermal power generation in India. And Section 5. Supercharging efficiency, advanced boilers take center stage. India is constantly looking for ways to improve the efficiency of its thermal power plants. With the growing demand for electricity and the need to reduce carbon emissions, the country is exploring innovative solutions to meet these challenges. One of the most promising approaches is the adoption of advanced boiler technologies. One way is by using supercritical and ultra-supercritical boilers. These state-of-the-art systems represent a significant leap forward in thermal power generation technology. They are designed to operate at much higher temperatures and pressures than traditional boilers, which allows them to achieve greater efficiency and performance. These boilers operate at extremely high temperatures and pressures. Specifically, supercritical boilers function at temperatures above 374 degrees Celsius and pressures above 22.1 megapascals. Ultra-supercritical boilers push these boundaries even further, operating at temperatures exceeding 600 degrees Celsius and pressures above 30 megapascals. This allows them to extract more energy from the coal they burn. By reaching these higher operational thresholds, the boilers can convert more of the coal's energy content into usable electricity. This process not only maximizes the energy output, but also minimizes the amount of coal required for the same energy production. As a result, these advanced boilers are much more efficient than conventional boilers. Efficiency improvements can be as high as 10 to 15% compared to older systems. This means that for every ton of coal burned, more electricity is generated, making the power plants more productive and cost-effective. This means they use less coal to generate the same amount of electricity. Reducing coal consumption has multiple benefits, including lower fuel costs and a decrease in the environmental footprint of power generation. It also helps in conserving coal reserves, ensuring a more sustainable use of natural resources. This, in turn, reduces emissions and lowers the overall environmental impact. By burning less coal, these advanced boilers emit fewer pollutants, such as sulfur dioxide, nitrogen oxides, and particulate matter. This contributes to cleaner air and a healthier environment for communities living near power plants. The adoption of supercritical and ultra-supercritical technologies is a significant step towards a cleaner and more efficient thermal power sector in India. These advancements not only align with global efforts to combat climate change, but also support India's commitment to sustainable development. By investing in these cutting-edge technologies, India is paving the way for a future where energy needs are met responsibly and efficiently. Section 6. A powerful partnership. Thermal and renewable energy join forces. Renewable energy sources like solar and wind are gaining momentum in India. However, they cannot yet meet the country's massive energy demands alone. This is where thermal power plays a crucial role. Thermal power plants provide a stable baseload power supply. This means they can generate a consistent amount of electricity regardless of weather conditions. This baseload power is essential for maintaining grid stability as more intermittent renewable energy sources are added. Thermal power acts as a reliable partner to renewable energy. It ensures a secure and uninterrupted power supply for India's growing population and economy. Section 7. Looking ahead. The future of thermal power in India. As we move forward into a new era of energy production and consumption, the role of thermal power in India remains a topic of significant importance and debate. Thermal power will continue to be an important part of India's energy mix in the coming years. Despite the global shift towards renewable energy sources, thermal power, particularly coal-based power, will still be a cornerstone of India's energy infrastructure. This is due to the country's vast coal reserves and the existing infrastructure that supports coal-based power generation. The country is committed to providing affordable and reliable electricity to its citizens. With a growing population and increasing industrialization, the demand for electricity is set to rise exponentially. Ensuring that every household and industry has access to uninterrupted power is a priority for the government. Thermal power plants will play a key role in achieving this goal. These plants are capable of generating large amounts of electricity and can operate continuously, providing a stable and reliable power supply. This is crucial for supporting the country's economic growth and development. However, India is also committed to reducing its carbon footprint. The environmental impact of thermal power plants, particularly those that rely on coal, cannot be ignored. The government is aware of the need to balance energy production with environmental sustainability. This means that thermal power plants will need to become even cleaner and more efficient in the future. Innovations in technology are paving the way for more efficient power generation methods. Advanced technologies such as supercritical and ultra-supercritical steam cycles are being implemented to improve the efficiency of thermal power plants and reduce their emissions. India is investing in research and development of new technologies. The government, along with private sector partners, is funding research into cleaner and more efficient thermal power generation methods. This includes the development of carbon capture and storage technologies, which can significantly reduce the amount of CO2 released into the atmosphere. These technologies will help to reduce emissions from thermal power plants. By capturing and storing carbon emissions, these technologies can mitigate the environmental impact of thermal power generation. Additionally, the use of emissions filters and other pollution control technologies can further reduce the release of harmful pollutants. The future of thermal power in India is about finding a balance between energy security and environmental sustainability. as the country continues to develop. It must ensure that its energy needs are met without compromising the health of the environment. This will require a multifaceted approach, combining the strengths of thermal power with the benefits of renewable energy sources. By integrating renewable energy with thermal power, India can create a more sustainable and resilient energy system for the future.